Hello YouTube, welcome back to another video on my channel. I am Samarth, and in this video we are going to learn more about Flutter. In this video we are going to build an animated loading controller just like the one that we have here on the iPhone simulator from scratch. So as you can see that this is a nice animation that you can display to your users while your application is doing something in the background. When your application is done doing whatever it is doing in the background, this loading indicator will not be displayed to the users anymore. So that's the basic concept. You might have used the built-in progress indicators that come with Flutter, but this is something that we are going to build today, and then you can just go ahead and use this in your applications. So let's observe this a little bit. As you can see that this loading indicator is a combination of a number of dots. There is a big dot in the center, and then we have smaller dots that are revolving around the center dot. Also, the radius of dots are different. The center dot has a bigger radius while the smaller dots have a smaller radius and are of different colors as well. So let's get cracking. First of all, I'll just go ahead and create a new Flutter project. So here I have created this brand new Flutter project. As you can see, I have all the boilerplate code, and the first thing I'll do is go ahead and clean this code a little bit. There are so many comments and I'll just get rid of all these comments. And now my document is much smaller. Let's run this project and make sure that everything is okay. While our application launches, let's get rid of everything that we do not need. Now what I'll do is I'll go ahead and create a new file for this animated loader. Let's call it loader.dart. Inside this file, I'll import the usual material class, and then I'll create a stateful widget. Let's call this widget as loader. Okay, now I'll go to my main.dart and import this loader.dart file, and to the child of my center widget, I'll just pass in loader. Alright, let's save that. And now you can see that I do not get anything on the screen, and that's because the loader class that we have just created doesn't have anything. The widget just returns a blank container. So now we can just focus on working inside our loader class, and this is where we'll be creating our animated widget. So we'll start with the basic setup. First of all, we'll have to create an animation controller, and then we'll create a number of animations. Inside this animated loader, basically we have three kinds of animations. The first one is the rotation animation, which rotates all the dots around the central dot. Second one is the animation where all the surrounding dots come towards the center and disappear. And the third animation is where all the dots emerge from the center and start rotating again about the central dot. We'll be creating three basic animations, and all these animations will be controlled by a single animation controller. So first of all, we'll use single ticker provider state mixin because we'll be using animations, and then we'll just go ahead and create an animation controller. We'll also create three different animations, and all these animations are of the type double. So the first animation is the rotation animation. The name of the instance is animation_rotation, and just like that, I have created two more animations of the type double: animation radius in and animation radius out. The radius in animation will be responsible for animating all the surrounding dots towards the central bigger dot, and the radius out animation will do just the opposite. Now that we have defined all the required variables, we can get started with initializing them. Before that, let's define a separate widget called dot so that we don't have to write the code to render a dot on the page over and over again. So here I'm just going to create a stateless widget. It will be called as a dot. Okay, and what this dot widget does is that it receives a parameter called radius, and this will be of the type double, and it also receives a parameter of type color. And now we'll write the constructor to initialize these values. Alright, so now that we have received the radius and color, we'll use this radius and this color to render a dot on the page. So let's see how we can do that. So we have a container here, and I'll just go ahead and define a width on this container, and the width will be equal to this dot radius. I'll also define height, and this will also be equal to this dot radius. Now I need to give this container a color and the circular shape, and for that I'll use decoration. I'll give it a box decoration, and in here I can define in a color, and the color is going to be this dot color, and I'll also define the shape using box shape dot circle. I'll save that, and now our dot is ready to be used. Coming back to the main widget here, inside our container, I'll define a width of 100 units and a height of 100 units as well. I'm just assuming that my loader will take 100 units of square space on the screen. I'll give it a child, and the child is going to be of the type center. So all my dots will appear in the center of this 100 by 100 units of container. In here, I'll just define a stack, and inside this stack, I'll define all my dots. So the first thing I'll have to do is define the central dot, which is the bigger dot around which all the other dots are revolving. So I'll just use my dot widget, and I'll pass in radius to be equal to around 30 units, and I'll pass in the color of this dot to be equal to colors dot black 12 or something like that. So it will give me a shade of gray on the screen. And here you can see that I have my dot. Now this is the central dot, and I need to position all the other smaller dots around this central dot. Alright, so let's see how we can do that. First of all, I'll just go ahead and create a simple dot using the radius, and I'll give it a radius of 5 units, and I'll give it a color red accent. I'll save that, and now you can see that I have my dot, but it is not correctly positioned. So to position this dot, I'll use a widget called transform.translate, which takes in an offset value, and within this offset I can specify the x and y value with which I want to move this dot away from its current position. Now we need to find a logic that we can apply to all the other dots, and all the dots will appear in a circular fashion around the central dot. And that's where trigonometry comes in. So the x value is going to be the cosine of the angle in radians at which we want to place this red dot. So if I pass in pi in here, and for that I'll have to import the math.dart file. And if I pass in sin pi for the y value, okay, I imported the wrong file, and now the error goes away. So as of now, it doesn't move anywhere, and that's because the value that's returned by cos and sine can only range between 0 and 1. The value cannot be greater than that. And to make this value significant, we'll multiply this value by a factor, and that factor is actually going to be the radius at which all the dots are going to be placed around the central dot. So let's define a variable here, call it radius. Okay, this is going to be of the type double, and let's set this radius equal to 30. And now instead of just passing in cos pi and sin pi, I'll multiply each of these values with radius. I'll save that, and now you can see that the dot has moved significantly. Also, if you notice, the dot, when the cos values and sin values were resulting in 0, dot wasn't in the center, and to fix that, I'll come down here and make this container a child of center. Okay, so now you can see that the dot has been placed exactly where it should be. So cos pi, which means cos of 180 degrees, is -1, and sin pi, which means the value of sine 180 degrees, is 0. So if you look at it like a coordinate system, you can see that the value of x is negative and it's actually minus 30 as of now because the radius is 30 and the value of y is 0. So the dot is placed on the x-axis in the negative quadrant. Now let's go ahead and place more dots, and while we do that, you'll understand what I'm doing a little bit better. So I'll just go ahead and place the second dot, and I'll place my second dot at pi by 4, which is equal to 45 degrees. Basically what I'm trying to do is have 8 dots around the circle, and to have 8 dots, each dot needs to be as an angular distance of 45 degrees or pi by 4 radians. So that's why for all my smaller dots, the angle needs to differ by pi by 4. Okay, so let's just go ahead and change this one as well. Let's make this pi by 4 and let's make this 2 pi by 4, or you can also go ahead and type in pi by 2. Okay, let's save that. And now you can see that both these dots are just next to each other. And that's because the angle only differs by pi by 4. Let's go ahead and copy this a number of times, and I'll paste them, and I'll fast forward this video while I do that. Let's save that, and now you can see that I have 8 dots around the central dot at a distance or a radius of 30 units. As of now, it is hard coded and the value is 30. So if I change this value now, you can see that the dots move closer to the center of the central dot. If I make this value larger, the dots will move further away. So this is what we are going to use to achieve the animation that we want. We are going to animate the value of this radius within a range to make our dots animate towards the center and then animate out from the center until the value reaches the radius. So for now, I'm just going to fix this value to 30, and now it's time to define our animations. So I'll just go ahead and override our init state function. And this is where we'll be initializing the values of our animations and our animation controller. So first of all, I'll just go ahead and initialize the value of my animation controller object, which is controller, and I'll just go ahead and type in animation controller. VSync is going to be this. For now, let's just go ahead and define a duration value of around, let's just keep the duration large for now so that we can see everything happening clearly. So the duration of 5 seconds is good as of now. Now I'll just go ahead and define all my 3 animations. So I'll just start by defining my animation for radius n, and this will actually be a tween, and this will be of the type double, and the value of this tween will begin at 1.0, which is the maximum radius, and it will end at 0 radius. Put a dot and use the animate function, and here I can just pass in the curved animation object, which will take in a parent, and the parent is going to be our controller. And optionally here I can specify a curve. We'll define an interval value, and this lets us specify a begin and an end value that lets us define how far in the total animation this animation will take part. So considering that our animation runs from 0 to 1, I want this animation radius n to work only in the last quarter. So it should begin when the animation reaches its last quarter, so the value will start at 0.75 and end at 1.0. And I'll also define in a curve, and the curve is going to be curves elastic n. Okay, let's format this, and now I'll just go ahead and copy this and paste it for my animation radius out. So I'll just change this value to animation radius out, and I'll change the animation curve to elastic out, and this animation will work only in the first quarter of our total animation. So the value will start at 0 and will go up to when our animation completes its first quarter. Now all we need to do is make sure that these animations control the value of the radius that we are using to build the user interface. So here we have this double called radius, but since the value of this radius is fixed, we need to have a variable that can actually affect this radius value, which we are using for offsetting all our smaller dots. So here I'll just go ahead and change this value and call it initial radius. Okay, and I'll create another value, call it radius, and initially I'll just go ahead and set it equal to 0. Now I'll go ahead and update the value of this radius variable, which we are actually using inside our offsets, and we'll evaluate the value of this radius variable based on the value of our animations and the initial radius. So I'll just go ahead and write in a listener for my animation controller. So I'll just go ahead and type in controller.addListener, and this is actually a function that is evaluated every time your animation makes some progress, which is actually around 60 times in a single second. So this function will be executed every time your animation does something or takes a step further in the whole animation process. And this is where I'll just go ahead and update the value of my radius. Now I want the value of radius to be affected by our animation radius in only in the last quarter of our animation, which is when the value of controller is between 0.75 and 1.0. So I'll just go ahead and type in if controller.value is greater than equal to 0.75 and if controller.value is less than equal to 1.0. Then in this case I want my animation radius in to affect the value of my radius. So I'll just go ahead and type in radius equal to animation radius in dot value, and I'll multiply it with my initial radius. Else, inside this else if, I'll just check if the value of animation is greater than equal to 0 and is less than equal to 0.25, which means that we are checking if we are in the first quarter of our total animation. And if we are, then I'll use my animation radius out animation to affect the value of my radius. Finally, we need to start our animation. So I'll just go ahead and type in controller.repeat. Oh, okay. I need to change this animation radius out's begin value to 0 and the end value to 1. And also I need to move all this code inside a setState function so that the state is updated and this radius value actually affects the UI that we are building. Let's save this now. So now you can see that the dots are actually animating. They animate back into the center, and as soon as they touch the center, which is when the controller's value reaches 1, they animate out instantly and then they stay just like that. So half of the animation is done, the radius is animating, and now all we need to do is just animate the rotation. And to do that, I can wrap this stack or the center tag that I have here within a widget called rotation transition. So I'll just move my stack inside rotation transition, and the rotation transition takes in a child, which is our stack obviously, and it also takes a parameter called turns, which should be equal to an animation of type double. And this is where our rotation animation comes in. So I'll just pass in my animation rotation, which will control the rotation of this whole stack. So our animation rotation is nothing as of now. We have not initialized it to anything. So now let's just go ahead and do that. So here in my init state, I'll just go ahead and type in animation rotation, and this will also be equal to a tween of type double, and this will also have a begin and end value. So it will begin at 0, it will end at 1.0, and I'll use the animate function that returns an animation object, and I'll pass in the curved animation. The parent for this curved animation is going to be the controller itself, and for curve I'm going to pass in an interval. So this is just like the other two animations. The interval takes in a begin value which is going to be 0.0, the end value which is going to be 1. And finally I'll just go ahead and define in a curve, and for this animation the curve is going to be curves.linear because the rotation needs to be linear. Let's restart our application, and now you can see that the rotation is there, the dots are rotating, and the radius of all the dots is also animating. So we are nearly done with our animation. Let's just go ahead and make this a little more exciting. So I'll just go ahead and change the colors of my dots. And now if I save, you can see that the color of all the dots changed. You can define colors of your choice. You can even manipulate how this loading indicator looks for you. You can modify the value of radius for your dots. You can also modify the value of this initial radius to make your dots move away or closer to the center of this animation. So if I change this value to 15 and if I restart my application, you can see that the dots are now closer to the center and they are actually overlapping the central dot. So we can just go ahead and reduce the size of the central dot as well to match this animation. And now that I've reduced the radius of the central dot to 15, this just looks perfect. So here you have the final animation that we built in this video. You can change a lot of parameters to make this work just the way you want, and you can play around with it to get different kinds of results. If you like this video, give it a huge thumbs up and share it with your friends and colleagues. Thanks for watching.